But now that we've done that, talk a little bit about, this is the motor shield here. And I'm going to go ahead and pull up the program that's actually on the motor shield today. I'll show that to you a little bit here. Like I said, it's written all in C, and so all of the, you import your classes just like if you're writing a C program. Here you're going to see a little bit of integration with the motor shield. There's actually some stuff you download, some libraries. You pull in those libraries, and once you have that installed, you can control the motor shield. And every shield, a lot of them have their own libraries. Many of the libraries are already included in the Arduino software. The Arduino software is free. It's currently in version 21. I'm actually running version 17 on my netbook, but the newest Arduino, the Uno, requires version 21. Like I said, it's all very basic. There's thousands of tutorials, thousands of already pre-written software you can take and rewrite, and it's all basic if statements. And so basically, what this actual unit does, I'll turn the power on here. What I have here is an input switch, and when I push that, it actually turns on the motor. That's the theory anyway. Shut off the battery. All right then. The nice thing about this is the 9-volt battery just died, but you can actually run it off of a USB cable. So I'm going to go ahead and plug in. There we go. Now then, I've got this button set up to trigger the programming. So it actually starts the wheels spinning. And what this is actually programmed to do is for 1,000 milliseconds it goes forward, and then for 1,000 milliseconds it goes backwards. And I'll show you that part in the code. Okay. Right here in the code, you can see that we've got the pins set. Initially, the pins are all set to high, and once you push the button down, it actually sets it to low. And there's an if statement to check exactly what is going on. And there's a variable in here called button count, BTNCT, button count, and it basically adds a count to it. And once it's set that, it's also looking for another set of functions, but we're going to ignore that for now. But here's the basic if statement. Once you've pushed the button, it adds 1 to the button count variable, and then it goes in and starts turning the motors on. And then here's I have a variable in here set for, it's called durvar, which is duration variable. And so the general variable that's set is for 1,000 milliseconds. So when I push the button, it sets the count to +1, and it starts running for 1,000 milliseconds. Now, I've added a second button just to show the functionality of the system, and when I push this button, light comes on, and now this is set to 2,000 milliseconds. And that is the second if statement that was at the top there that I skipped over. Right here, it just sets durvar to 2,000, and if it's pushed down again, it sets it back to 1,000. And it also turns the light off. But the really neat thing about, I also have it set up to where when you hold the button down, it actually turns everything off. But the really neat thing about Arduino is the fact that it is a prototyping platform, and you can actually watch what it is doing in the serial monitor. Earlier I mentioned that you can connect multiple devices together via serial, and this is the serial monitor here. You're going to notice it's all pushing zeros. I'm a remote control car from Walmart. I pulled all the guts out, replaced it with this. I actually put light sensors in it so that it would know when it drove underneath a cabinet or a chair or a couch. And I also put button sensors on the front, so if it hit something, it would back up and drive around. The wheels weren't big enough for it to drive on carpet, so I went ahead and moved to this. Only problem with this is that it doesn't have the motor in the back wheels to make it turn. So it's fun to watch and play with, but it's not very practical. But anyway, motor shield. It's available on adafruit.com, and it's also available on smartphone.com. I guess next I'm going to show you the Ethernet shield, which is already being demonstrated by my partner back there. On my cell phone here, I'm running an HTC Desire. This is it's basically just a website. The Arduino has, it's called the Ethernet shield. There we go. You can see the Ethernet shield is this top part here. It's just got a regular Ethernet connector, RJ45, and it's got a chip to run the processing. And basically what we've done is set up a wireless network on this Linksys router, and it is providing internet connectivity to the Ethernet shield, and then we've got a couple of devices connected to it. This is actually a screw terminal shield, which is another kit that you can buy, and it makes prototyping a lot easier because you're not having to shove wires down into these little bitty holes. It allows you to connect and hold them. But on the Arduino, in its memory, is this website. And it's a very simple website, and all that it has on it is a couple of controls, and I've got an on and an off button. And so there we go. Push the button on the phone, it goes off. Actually, I can see it a little better. There we go. You can see that a little better. Very simple code. Anything that is browser capable will run on this. Since this doesn't have any kind of back-end server software on it, such as ASP or Linux or anything like that, whatever you run through the browser has to be very simple. So anyway, like I said, just push the on button, lamp comes on. Push the off button, lamp goes off. So very simple, and of course the pumpkin on. So the really neat thing about that is you can compile a huge program into the Arduino that can run all of your Halloween lighting. You can put motion sensors. You can also, using your cell phone, as you pull into your house, you can log into your wireless network, or if you've got your network in your home already connected to the internet, you can just connect to your home IP address. You can, before you even walk in the house, have your coffee machine going, have your lights coming on. The neat thing is, if anyone's familiar with Home 10, it's a product where you can do I/O terminals like this. You can actually control it with the Arduino. And so any of this that you're doing here, you can do with this. And this is, and many times, a lot cheaper than going with the Home 10 system. But that's kind of the home automation thing. In addition to that, you can connect this up with a wave shield and do your Christmas light decorations. Those are kind of the big rage, having the animated lighting displays for your home. And so, just being able to do that. If someone walks up to your house and you can scare them with ghosts or whatever, they're all controlled like that. So that's the Ethernet shield. And of course, over here with the wave shield, we've got, there's the Ethernet shield, sounds and lighting. This is actually running LED lighting directly to the switches, and so rather than having to have some sort of standard lighting, you can do LED, of course, which is less heat, doesn't have to be replaced as often, and so. We've got the two Arduinos. This is the wave shield. This is a prototyping shield. The two units talk to each other via TTL serial, and so one takes in the command and sends out the lighting, and one actually plays the audio. The audio is actually on an SD card, and the volume control is here, of course, and it's it's all USB, just like the other Arduinos. These are standard arcade buttons. It's another hobby of mine, is working on arcade cabinets, so those around. Yeah, that's how that works. The Sounds of the Trail exhibit actually won an award just a few months ago at the Oklahoma Museums Association for Outstanding Interpretive Exhibit. And like I said, it's built entirely on the Arduino system with some code that I wrote to make it happen. So the skills that are required to do this, I'm not in any way electric. I have no electrical degree or any kind of schooling in electronics. All of this was hobby. I actually learned how to solder online at the NASA website. They actually have a tutorial on how they expect you to solder. And so I actually followed their tutorial and learned how to solder. The first thing I actually ever soldered was this board. And you can see how much better I've gotten. But and every single one of these shields you can get from these websites, Adafruit.com and SmartFun. They all come with a tutorial on how to put them together. Some of them you can order already put together, but I think it's just as much fun to get them and put them together yourself. And a lot of times, when you get these, they're designed to be used by themselves. And so I have taken the liberty of, when I get these, I keep a stock header pins, which are just the little pins that stick out. And I keep a stock of them, and I get the larger ones so that you can actually stack them. You can stack multiple of them together so that you actually, rather than, in this particular shield, I can pass this around in a second. We've got one row of standard pins, which look like this. And then there's another row of pins on the back that look a little bit like this, but they're shorter. So they look like this exactly. And the sad thing about that is the pin that's actually sticking out is very, very short. And so when you've got the longer header pins, you're actually able to stick it through here, have the pins on the top that you can prototype with, and you can also stack them on top of other shields because there's still enough room to lock on.